Ever wondered why loops are considered the backbone of programming? Well, it's because they allow us to perform a set of instructions over and over again, making our code more efficient and our lives as programmers easier. Today, we're going to dive right into the heart of these cyclical marvels, exploring the world of iterative constructs in Java. We'll start by defining what loops are and the different types that exist. We'll then delve into the specifics of entry-controlled loops, like for and while, and exit-controlled loops, such as do-while. We're also going to discuss variations in looping statements and jump statements like break and continue. To make it more interesting, we'll illustrate these concepts with simple programs and even show you how to interchange between for, while, and do-while. So, are you ready to dive into the world of loops? Buckle up, because it's about to get loopy. So, what exactly are these loops that we keep talking about? Well, if you've ever found yourself stuck in a repetitive task, wishing you could just automate it, then loops are your knight in shining armor. In programming, loops are used to execute a block of code repeatedly until a certain condition is met. Think of them as a super efficient assembly line in a factory, churning out product after product without breaking a sweat. Now, there are two main types of loops in Java: entry-controlled and exit-controlled loops. Entry-controlled loops, as the name suggests, check the condition before entering the loop. If the condition is true, the loop is executed. If not, we move on. It's like a bouncer at the club, checking your ID before letting you in. The for loop and the while loop are the two types of entry-controlled loops. On the other hand, exit-controlled loops check the condition after executing the loop at least once. It's like eating a slice of pizza and then deciding whether you want another one. More often than not, you do. The do-while loop is an example of an exit-controlled loop. Now, you might be wondering why we need different types of loops. Well, it's all about flexibility and control. Sometimes we know beforehand how many times we need to run a loop, in which case, a for loop might be more suitable. At other times, we might need to keep running a loop until a certain condition is met, making while or do-while loops the perfect choice. So in a nutshell, loops are the perfect solution for repetitive tasks. They're like the magic wand that turns a tedious job into a piece of cake. Just remember, the type of loop you choose depends on your specific needs. Now, let's dive deeper into how we can control these loops. Now, let's get into the heart of the matter, the for and while loops. The for loop in Java is like a well-planned road trip. You know when you're leaving, the route you're taking, and when you'll arrive. It has three parts: initialization, where you set up your counter variable; condition checking, which is like your GPS telling you if you're still on the road; and updation, where you move forward on your journey. Here's what it looks like: for, initialization, condition, updation. Inside those brackets, you'll put your action, like sightseeing or stopping for snacks. Now, let's say we want to print the numbers 1 to 10. We start at 1, check if we're less than or equal to 10, then move up by 1 each time. It's like counting the number of pit stops on your road trip. The while loop, on the other hand, is like an adventurous hike. You know you want to keep going, but you're not sure how many steps you'll take. You only have two parts: condition checking and updation, and they're not as strictly ordered as in the for loop. You could find yourself checking the condition at the start of the loop, or somewhere in the middle. It's a bit more flexible, and looks like this: while condition. Inside those brackets, you'll put your action, and somewhere in there, your condition will be updated. Let's say we want to keep doubling a number until it's greater than 1,000. We start at 1, and while our number is less than or equal to 1,000, we keep doubling it. It's like climbing a mountain, doubling your height with each step until you reach the summit. Remember, a for loop is your go-to when you know how many times you want to loop, and a while loop is your friend when you're unsure. What if you want your loop to run at least once, no matter what? Enter the do-while loop. This is your friendly exit-controlled loop, always eager to run the code in its block at least once. It's like that friend who insists on having one last dance. Even when the party is wrapping up, the syntax is simple really. You start with the keyword do, followed by your block of code in curly braces. After this comes the while keyword and your condition in parentheses, ending with a semicolon. A bit different from while and for loops, isn't it? Now imagine you're creating a simple game where the player must guess a number. You want them to keep guessing until they get it right. This is where do while shines. It allows for the game to start regardless of the initial guess. So always remember, do while is here to save the day when you want at least one execution. Okay, we've got the basics down. Now let's spice things up a bit, shall we? Let's delve into the world of variations in looping statements. Picture this, a loop within a loop. Sounds like a sci-fi movie plot, doesn't it? But in the realm of programming, this is called a nested loop. It's like a matryoshka doll, where each loop is contained within another. Now let's venture into the territory of infinite loops. Imagine a record player that keeps spinning the same tune over and over again with no end in sight. That's an infinite loop for you. It might sound like a nightmare, but sometimes they're used intentionally in programs that need to run continuously until an external condition is met. Moving on, let's talk about jump statements. These are like the plot twists in our programming story. Break is a jump statement that, well, breaks the loop, terminating it immediately. It's like saying, okay, I've had enough, I'm out. Then there's the continue statement, which skips the rest of the loop's current iteration and jumps straight to the next one. It's like pressing the fast forward button on your remote. Now let's talk interconversion. You can often switch between for, while, and do while loops depending on your needs. It's like choosing between a car, bike, or skateboard to get to your destination. They all serve the same purpose, but the journey might be different. For instance, a for loop can be converted into a while loop by moving the initialization and update expressions outside the loop. So, you see, loops are not just about repetition. They're about strategy, control, and efficiency. They're a powerful tool in your programming arsenal, allowing you to manage complex tasks with precision and grace. And that, my friends, is how you can play around with loops and jump statements. You're now equipped to navigate the labyrinth of looping constructs with confidence and panache. Remember, practice makes perfect. So go ahead, let your creativity loose, and start coding. Well, that was a whirlwind tour of loops in Java, wasn't it? In this roller coaster ride, we embarked on a journey through the labyrinth of looping statements, exploring their various forms and functions. We've seen the entry-controlled loops, the for and while loops, which diligently check the condition before they leap into action. We also met their adventurous cousin, the exit-controlled do-while loop, who acts first and asks questions later. We've seen how they can be interconverted, morphing from one form to another like chameleons changing their colors. We also touched upon the variations in looping statements and the role of multiple counter variables in initializing and updating loops. We introduced you to the daredevils of the loop world, the break and continue statements who aren't afraid to disrupt the flow of things. And of course, we demonstrated all these concepts through simple programs to make this complex world a little more accessible. Remember, loops are like the heartbeat of programming. They keep the code alive, making it dynamic and interactive. They're fundamental to computation, and the more you experiment with them, the better you'll understand their rhythm. This journey, like all journeys, is far from over. There's much more to learn and many more loops to loop, so don't stop here. Keep exploring, keep experimenting. Dive into the ocean of codes and swim with the loops. Make mistakes, learn from them, and then make new ones. That's the best way to learn, isn't it? As we wrap up, don't forget to put into practice what you've learned today. Play around with different types of loops. Try to write your own programs. And most importantly, have fun while doing it. And that's a wrap. On behalf of SMPC Academy, I wish you all a happy St. Patrick's Day. May the luck of the Irish be with you in all your coding endeavors. Keep looping and keep learning. Until next time.